Planes are elegant, fast, and pretty interesting. But the problem is that they are too expensive to buy and to run. But a lot of person came with the idea of making models. This is cheaper, easier, you don't need license, and you don't have the risk to crash. It's fantastic. I think making models is much better because you learn so much things. So the plane I'm going to build is a 1/5 scale, which means it's about 2 meters long, so it will probably weigh about 10 kilograms. So I need a petrol engine of about 50 to 100 cc's. I don't want an electric motor because this is less realistic and you don't have the sensations I've talked about. But okay, you can find a lot of these engines on the web, but they have all only one or sometimes two cylinders. But I found this very boring because we see that everywhere. So I want something unique. So I think 4 is the best number. But there are no inline 4 on the web for an airplane, something pretty reliable, lightweight because it's an airplane. And they say don't buy, build it. So I'm going to build it. To minimize weight, I give this engine 2 chainsaw carburetors. As you can see, the engine has a kind of long nose. This is due to the plane design itself, because I don't want this engine going beyond the fuselage and neither offset the prop shaft from the crankshaft because this will require gears. Having the engine backup is better for the CG as this engine will weigh about 3 kilograms. Now let's deeply jump into the explanation of the design. I'm going to begin with the most uncommon thing on this engine, the crankshaft. As you can see, it is composed of multiple parts. There are a few reasons for that. Firstly, it allows me to set roller bearings everywhere. Secondly, it's easier to machine. You'll tell me that this is a stupid idea. Yes, it's probably a stupid idea. We'll see. But we are building a model engine, not a mass product engine that will run 5 hours a week, right? We don't need the cheapest cost of production and neither a cheap engine to run with crazy efficiency. Let's try to make this tech work. We can't properly machine the connecting rods. That's why they have been machined online. Plus, they are made of titanium. That thing will never break. I hope so. And yes, they are in one part as I can slide them in the crankshaft. One issue that mainly goes for the airplanes is the thrust caused by the props. That's why I thought it would be important to give the prop shaft a thrust bearing and to let a longitudinal freeness between the prop shaft and the crankshaft to keep the connecting rods, the cylinders, and the crankshaft aligned. Otherwise, the engine is pretty common. You will be able to deeply see it through the next videos. So for the ignition of the engine, I didn't want to DIY a CDI because this is too hard for me. I don't have enough knowledge in electronics, so I just prefer buying a CDI like this one, even if it's pretty expensive. In addition to that, I think that would cost the same to DIY it, and it's a bit risky because 20,000 volts pass through these cables, so I prefer not deal with these things.
No thanks, I choose life.
So I just say, take my money. Then what we can add is that it's very well made. It's pretty heavy. It's a metal box, which is very nice. I don't know if it's aluminium. I don't know, but the quality is decent. You have, of course, a tachymeter, and so this is made for an inline 4. The configuration of the crankshaft is perfect for me. I'm pretty lucky with this. Yeah. I think that's pretty much all. Now let's talk about the spark plugs which go along with the ignition box. Let me show you one very quickly. It's so small, it's amazing. So it's a 1/4 inch thread. So it's the same size as OS glow plugs. Here we are. So yeah, and it's made of iridium, which is pretty cool and pretty important. But the problem of making an inline 4 is that you have to buy everything 4 times. So the CDI box, it's nearly 4 times the price of a mono cylinder one. You have to buy 4 spark plugs, and this is just pretty annoying. So now let's jump into crazy things. So this is the FSK gas suit, which is extremely. This will be extremely. So now let me show you this gas suit made by FSK, which is completely insane. So this thing costs about 100 euros, but it contains 2 temperature sensors, 1 flow meter, and the main control box. First you can plug in the tachymeter output, which is just here, to know your engine and RPM from the ground on your radio transmitter. So this is amazing, I think. So those 2 sensors covers different temperature ranges. I think I'm gonna use this one to directly screw on the engine, and this one just to in the engine room, just to know for the security the temperature inside it, to know the cooling if it's correct. So now you can see what the engine looks like. So these are all the parts I'm going to make with the foundry process. They might have changed, and might be older versions, but they are quite similar to these parts. Of course, I'm going to machine them to get them extremely accurate. Now, let me show you the final part I've got for the plane, for the engine, which is extremely important for an airplane. It's the propeller. So here it is, guys. It is completely massive. It is insane. It is so huge. Here is a small or normal propeller, which goes on a 1 meter wingspan electric airplane, and this is just huge. This is my hand. My hand is not even as long as one blade. It's so huge. It has 4 blades. It's quite heavy. It feels very stiff, and the quality is just amazing. So it's, as it's written, it's 18.6 inches, so 47.3 centimeters. So it's quite big, and yes, as I said, it's a 4 blade propeller, which should produce a lot of thrust. It is beautiful, and its scale, it really looks like the real blade you find on the P-51, which is the plane, or kind of the plane I'm building, with this round shape at the end. So the last thing, which is very useful, it's the fact that the pitch is adjustable. So you don't need to buy 10 different propellers with different pitches. You can adjust it. You just have to unscrew a little bit the 8 screws all around, and you can adjust the pitch just by screwing the little hex screw here. So now you know pretty much everything about the new project. I hope you really liked the video, and see you for the next one.